Hello and welcome. This video explains how electricity enters our homes. We start by following the cable back to where the power is generated, for instance, inside a wind turbine. Here, the wind spins a propeller, which rotates a magnet inside a generator. As the magnet spins, it creates alternating current, AC, in the coils around it. AC means that the electrons constantly move back and forth. Since there are 1, 2, 3 separate coils, 3 different waves of currents are created. These are called phases, and they are slightly out of step with each other. These are the 3 phases that we will follow all the way to the house. So number 1, 2, and 3 we will follow. So the electricity travels long distances on high voltage lines. When it reaches your residential area, it enters a substation. It's a small building close by where you live. Here, a large transformer lowers the voltage down to, in Sweden, 230 volts, and in other countries, maybe 400 volts, used in our homes. From here, it travels underground to a cable cabinet, a distribution box, on your street, perhaps. Note that this cabinet simply distributes the power to the nearby houses. So here we have the 3 power lines with the 3 separate phases, which each is lowered in voltage, and they get to the distribution cabinet. So from the street cabinet, a cable goes to the meter box on the outside of your house, which is quite normal. Before entering, the electricity passes through 3 main fuses, 1 for each phase. This box also contains your meter that measures your consumption, which is of interest for the power company, so they know how much to tax you. The cables then pass through the wall into the distribution board, which is normally found in your hallway. So here we have the outside with the electricity meter and the 3 main fuses for the 3 phases. Here we have the house wall, and here we have the electrical panel on the inside of the house. So inside this panel, these 3 phases are split into different groups. Modern panels use automatic circuit breakers or switches. If a switch is up, the power is on. If a fault occurs, it flips down. You can see which flips. You can see which switch controls which room on this map here, like the kitchen or or upstairs. And if you plug too many, so the electrical panel distributes the phases through many automatic fuses to outlets and fixed installation. And a fixed installation is a machine wired permanently instead of using a plug. For example, your stove. If you have an older building, it might look like this. It contains a thin wire that melts when the current is too high. You must replace them when they blow. Automatic fuses can be reset, but only after fixing the cause. And this might be the cause. If you plug too many appliances into one outlet, the current becomes too high. The breaker senses the overload and trips to prevent overheating. So now we have come to the outlet and the plug and how they play together. This is how an outlet looks like in Sweden. You have 2 holes and a little metal bar. One of the 2 holes is the phase, and the other hole is neutral, but you can't know which one just looking at the outlet. So one brings the live phase current. The other is the neutral. The current flows in through the phase, through your appliance device, and back through the neutral to complete the circuit. And then the current flows back and forth all the time through the device. The neutral wire eventually leads back to the transformer station into ground. And this is the symbol for leading it to ground. There are also these metal clips in the outlet connected to what's called protective earth or ground, and it's connected by a yellow and green wire. This connects to the metal casing of appliances like a toaster, and let's look at that. But first, all neutral wires in the house collects into one conductor that returns to the meter. All protective earth wires also go here and are connected to ground nearby the distribution cabinet. Okay, so let's go back to a device like a toaster. Here you have a toaster, and here where the cable enters the toaster, here is the inside of the toaster. And here we have the neutral and the phase wires, and here you have the and here is the yellow and green protective earth wire. So what is the purpose of this? Imagine a wire inside the toaster breaks and touches the metal casing like here. Then the casing would become live, and if you touched it, the current would flow through to the ground, and it could be fatal for you. But with the grounded wire connected, the current takes the easier path through the ground wire instead of you. This rush of current instantly trips the circuit breaker. Additionally, modern homes have a residual current device, an RCD, which detects that electricity is leaking out of the system and cuts the power in a split second to save your life. And finally, all protective earth wires gather here, and they are led out of the house together with the neutral wire, and they goes toward the ground connection. So, thank you for watching. This has been a very simplified, but perhaps you have a bit clearer idea of how electricity is brought to our houses. So, thank you again, and see you later.